Can you see the picture?
Yes, we can.
Okay, so I know that for most of you, it might be obvious how the PWM modulation works, but I'm assuming that's not for everyone. So this is this simplified explanation that we can drive in this case of LED light intensity by changing the duty cycle from 0 to 100, where the 100 is full DC, and the 0 is the, we can treat it as the 0 voltage. So what is interesting is the voltage level is always, the voltage is always at the same level, but what we are regulating is the duty cycle, which from the load point of view is the total amount of the energy. And it can be a regular light bulb, it can be a motor, but of course, in order of current limitation of our MCU pin, we have to drive them through some switches like NPN or MOSFETs, transistors, or something like that. And the PWM modulation has actually two basic parameters, which might be a little confusing. The first is, of course, the duty cycle, which is the ratio of the the pulse length to the full cycle. So in this case, the duty cycle is something around 20, and in the when our pulses is getting thicker, the duty cycle is something around 15 or 20. And the second one is the frequency, and in most cases we've set the constant frequency, and we are changing the duty cycle, and this is this case. So the frequency, if you can see my my mark here, is from this point to this point. Of course, the frequency is the reverse of the full cycle, because we are in the time domain. But simplifying, the frequency is the reverse of the time cycle. And this is the general operation of PWM modulation. And the second picture, one moment. Okay, can you see the different picture with the detailed explanation? Okay, so in very general, we can divide our PWM as the output, which is there. And if you would connect the, for example, the oscilloscope probe or the logic analyzer probe to the output, and in our case, the ground, you would see the changing duty cycle. But this is the final result. But here, what we are changing, and what we are setting is the value from the auto reload register in our case. So this is the value from we are counting down or up. Generally, in our purposes, it doesn't matter. The LED intensity will change in both cases, and the we can call it a comparison point. So if I set this comparison point in here, we will get the duty cycle something around 15, 20, something like that. And if we count down, and if we use almost the full result of our timer, we will achieve almost the DC wave. Let's call it the DC wave. Practical, this something like 99.9% of the duty cycle, and then the cycle repeats. And it may look difficult, but if you want to just set the PWM in constant duty cycle, you can just set those values, in our case, the comparison point, at the constant value, and you will get the constant duty cycle. I assuming that most of you use the some simplified software like Arduino, which is the high languages for MCU, and you have the function PWM, and the parameters of this function is actually duty cycle. And if you would see at the register basic level what those function does, it actually changes this register content. Okay, one more thing. And this is a very general and very brief explanation of how the PWM waveform is generated. So we have a counter, and we have the comparison value And here in this node, we have the a comparator. In our case, it is the digital comparator. You can create the PWM waveform by using some other circuits, like for example the NE555. You can create your own circuit which can generate the PWM. It always consists some sawtooth waveform and some other waveforms. Waveform in our case is the digital domain, but the general look at the timer always consists the comparator and some sawtooth sawtooth wave which we are comparing with. And going back to the STD, one second. So we are, in this case, we are setting the maximum internal clock. Before that, sorry. We have to enable our clock for timer-free peripheral. And same like in our previous exercise, we have to set the prescaler value. In this case is to power of 15. We are counting to 256. Then we are comparing this value, which is already in the auto reload register, to the value in compare register. It is important to to use the proper channel comparing register. And then in CCMR, we are setting the PWM mode, and actually the last instructions is to set our our LED as the output, and the bit number 0 is the CEN that which enables the timer, and that's it. I have a problem with the simulator in the STVD, so hence also your tasks is independent from the code almost. So all you need to do is to describe the theory that I've mentioned, but based on the reference manual. to describe what actually those registers are responsible for. And from my side, that's all. Is there any questions?
So what's the deadline for the report?
I repeat once again, please note it. I will also upload this information to the portal Thursday, 6 p.m.
Okay, thank you.
Thursday is January 27th, 6 p.m. Then I will create the separate folder for those who are late. In this case, I hope you all of you will be on time. Okay. Any other questions?
So the example which you have showed us with the label from the microcontroller where the additional LED is applied is only example, or we should do so? Because I mean, for the second task, which of these pins are occupied? So if, let's say, some pins are occupied and they are occupied by this LCD screen, we should just write this, or also give the example of other usage?
Just describe that they are occupied, and by which peripherals. In our case, is the LCD segment display, and that's all.
Okay, thank you.
But my general suggestion is to use the full sentence manner. Okay, that's as the example that I've shown you at the beginning. Using some more sophisticated sentence and that manner in general. Okay, if there is no question, thank you. If someone's would like to attend at the last classes, just give me, write me email and inform me. Because if your situation is clear and you have the positive test mark, the any other labs you have you've attended to each classes, or if not, you've make up them in some way that you can. There's no need to attend at the work of term, and the persons who would like to improve the test grade, please write me the email. I need this information because I need to I need to know how many questions I need to figure it out. And as for those who would like to improve their grade at the last term, in our group, the test start at the 4 p.m. If you have some reasons that doesn't fit to you, just let me know earlier. Maybe we will figure out to change this date, because I have information that some of you has the test from the lecture also, so I don't want to disrupt your lecture, and I want to give a chance for all of those who would like to improve their grades, and that's it. So if there is no question, thank you and goodbye. And if someone has some individual question, I'm still here until everyone disconnects. So have a nice evening and goodbye.
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 Bye.
Goodbye.
Bye.